Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 3 video on the chapter properties of triangles, I will discuss about the concept of triangle inequality, which is about which is about a relation between the length of the three sides of a given triangle. And finally, I will solve the problems of exercise 15C from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I highly suggest and request you to please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. And also, if you have not watched the previous part 1 and part 2 videos, please do watch them to maintain the continuity of your study on the chapter properties of triangles. So let's get started with this video. Okay, so I have my rough notes prepared on the left hand side, and on the right hand side I will discuss the concepts and will solve the problems from exercise 15C. So this video is about the triangle inequality. Now before that, in a triangle, you can see in the triangle ABC, the usual convention is that the side BC, the side which is opposite to the angle A, is named considered to have the length small a. That is, the BC is equal to A. Now BC is the side. BC is denoting the side BC which is opposite to the angle A, and we normally denote the value of the length of the side BC with small a. Similarly, the length of the side AC is denoted with small b. Why small b? Because it is opposite to the angle capital B. Similarly, the side AB is denoted with the the length of the side AB is denoted with the small letter c, which is opposite to the angle C. Okay. Now with this convention, what is triangle inequality? Triangle inequality says that the sum of length of any two sides in a triangle is always greater than the length of the third side. So with respect to this triangle ABC, we will have three inequality, that is the A plus B, that is the side the sum of the length of the sides BC and AC will be greater than the length of the side AB, that is A plus B is greater than C. Similarly, for the other two sides and the third side, we will have B plus C equals greater than A and A plus C is greater than B. So this states that for any two sides of a triangle, we will have the sum of the length of those two sides will be greater than the length of the third side. Now a similar inequality states that the difference of length of any two sides in a triangle is always less than the length of the third side. Now the difference, by difference it means the absolute difference, like if two sides, one could be smaller and one could be larger, by difference we mean the absolute value, that is the modulus of the difference of the length of the two sides. So with respect to the triangle ABC in the figure, the triangle inequality number 2 says that modulus of A minus B. Now what is A minus B? A minus B is the difference of two sides of the sides BC and AC. It will be less than small c. Similarly, we will have modulus of B minus C will be less than A, and modulus of A minus C will be less than B. So the main triangle inequality is that the sum of length of any two sides is greater than the length of the third side, and from this I am not sure about the proof of this inequality. It is not given in the book, and I guess from this main inequality, the second inequality has been derived. That is, the difference of length of any two sides is always less than the length of the third side. Okay, so these are the two triangle inequality. Now, based on these triangle inequalities, important results, we have some important results. Number one is that if we have three positive numbers x, y, z, that is x greater than 0, y greater than 0, and z greater than 0, and if we have and the conditions and three conditions hold, that is x plus y is greater than z, and y plus z is greater than x, and x plus z is greater than y. That is, if we are given three positive numbers x, y, z, and the sum of any two of these numbers is greater than the third number, then we can say that a triangle can be formed. Having the length as x, y, z of its three sides. So in the notes you can see that I have tried to visually explain this, that if the three inequality, that is x plus y greater than z and y plus z greater than x and x plus z greater than y holds, then it implies that a triangle can be formed where ABC, where the length of its three sides are x, y, and z. This is an important result following the main triangle inequality. Now, another results is that if the length of two sides of a triangle is given, let's say the length are x and y, it is said that the length of two sides of a triangle is x and y, then what can be the length of the third side? So in the notes you can see, in the triangle ABC we have the length of the sides AB and BC is given to be x and y, and if we assume that the length of the third side is z, then what can its value be? So in the notes we assume that the length of the third side is z. So now from the triangle inequality we can say that x plus y will be greater than z. This implies z will be less than x plus y. So let this equation be 1. So we have z less than x plus y. And also we also know from the second triangle inequality that the difference of any two sides, the difference of length of any two sides is always less than the length of the third side. So we can say that modulus of x minus y is less than z, or we can say that z is greater than modulus of x minus y. So now from these two inequality 1 and 2, we get that z must be greater than modulus of x minus y, that is the difference of the two difference of length of the two given sides, and z will be less than the sum of the length of the two given sides. This is another important results that we can obtain. Okay, so these are the concepts for this video, which is mainly centered around the triangle inequality, that is the sum of length of any two sides in a triangle is greater than length of the third side, and that the difference of length of any two sides in a triangle is less than the length of the third side. And we have these two important results based on the triangle inequality. Okay. Now let's based on these concepts, let's try to solve the problems of the exercise 15C. Now let me see if you can, I hope you can see the problems of exercise 15C. Let me check. Yes, you can see it. So let's start solving the problems of exercise 15C. Problem number 1 says, is it possible to draw a triangle the lengths of whose sides are given below? So the lengths of the sides of a triangle are given, and we have to check whether whether a triangle can be formed having having the given lengths as its sides. So basically we have to check, we have to use the triangle inequality, that is, uh, let's say, so part 1, we have to check that the sum of the lengths of any two sides must be greater than the third side. So first let's check. Let A be 1 centimeter. Let B be also 1 centimeter, and C is also given to be 1 centimeter. So now we have to check uh, A plus B must be greater than C. Now this implies that A 1 plus 1 is greater than 1. This implies I'm omitting the ignoring the unit of the length, centimeter. I hope you can understand that the units are in centimeter. So this implies 2 greater than 1, which is true, which holds, which is true. Also we have to we have to see that B plus C must be greater than A, and obviously since all the lengths are equal, that is 1 centimeter, it will obviously hold, that is B plus C will also be greater than A. So we will have 1 plus 1 greater than 1. This implies 2 greater than 1, which is true. And finally we have to check C plus A greater than B. This implies 1 plus 1 greater than 1. This implies 2 greater than 1. So this is also true. So we see that the sum of the length of any two sides is greater than the third side. So for part 1, the given lengths, the triangle, yes, I am writing yes, meaning a triangle can be formed. Now I will not solve all the 5 parts. It is very obvious, and the concept is very obvious. You can easily solve the remaining problems. So let's do 2. Let A be equal to 2 centimeter. Let B be equal to 3 centimeter. C equal to 4 centimeter. Okay. Now first let's check A plus B greater than C. This implies A is 2, B is 3, and C is 4. So this implies 5 is greater than 4, which is true. So A plus B greater than C holds. Now we have to check B plus C greater than A. This implies B is 3 plus C 4 greater than A is 2. So this implies 7 greater than 2. This is also true. And lastly we have to check C plus A is greater than B. This implies C is 4, A is 2, is greater than B is 3. So this implies 6 is greater than 3, which is also true. So all the conditions hold, that is the sum of the sum of length of any two sides is greater than the third side. So with this length a triangle can be formed. Okay, let's see anywhere. Let's solve all the problems. Part 3, let A equals 7 centimeter, B equals 8 centimeter, and C equals 15 centimeter. We can clearly see that we can clearly see by seeing the length, given lengths, that A plus B is equal to C, or we can say that A, what happened? Uh, we hope everything is fine. Okay. We can see that A plus B is definitely not greater than C, as A plus B equals 7 plus 8 equals 15 equals C. We can see that A plus B is equal to C, but we have to ensure that A plus B greater than C. So no triangle can be formed with this length as its sides. Part 4. The lengths are, let A equals 3.4 centimeter, B equals 2.1 centimeter, and C is equal to 5.3 centimeter. Now let's check A plus B greater than C. This implies 3.4 plus 2.1 is greater than 5.3. This implies 5.5 is greater than 5.3. This is true. This is true. Let's see B plus C greater than A. This implies B is 2.1 plus C is 5.3 greater than A is 3.4. This implies 7.4 is greater than 3.4. This is true. This is true. Let's see, C plus A must be greater than B. This implies C is 5.3, A is 3.4 is greater than 2.1. This is, we need not solve it, this is obviously true. So a triangle can be formed having the given lengths as its sides. Okay, let's do part 5. So let A equals 6 centimeter, B equals 7 centimeter, C equals 14 centimeter. Now we can clearly see that A plus B equals 6 plus 7 equals 13, which is less than C. So therefore no triangle can be formed having the given lengths as its sides. Okay. So while I am solving the problem, you can pause the video and take a screenshot if you think the solution will help you. Okay, let's solve problem number 2. It says two sides of a triangle are 5 centimeter and 9 centimeter long. What can be the length of its third side? So we already know that what can be the length of third side. So let we know that let A is equal to 5 centimeter, let B be equal to 9 centimeter. By A and B, I mean A to be the length of the side which is opposite to the angle A. So A is 5 centimeter and B is 9 centimeter, and we have to find what can be the value of C. We have to find what can be the value of C, that is the length of the third side. So we know that from we already discussed that if two sides are given in a triangle, length of two sides are given, then what is the condition, what value the third side, what value the length of the third side can have. So we know that the formula, the formula is C must be greater than mod of A minus B, and C must be greater than a modulus of A minus B, and should be less than A plus B. So this implies that modulus of A minus B is 5 centimeter is 5 minus 9 centimeter less than C less than A plus B is 5 plus 9 centimeter. So this implies we must have 5 minus 9 is minus 4 and modulus is 4. So we must have C should be greater than 4 centimeter and less than 14 centimeter. So the length of the third side should be greater than 4 centimeter and less than 14 centimeter. Okay. Let's solve question number 3. If P is a point in the interior of a triangle ABC, then fill in the blanks with less than or greater than or less than or equal to. Okay, so the diagram is given. So there is a triangle ABC. So ABC is a triangle and P is a point inside the triangle, and the point P is joined the line segments. The point P is connected with all the three vertices. So we have the line segments BP, AP and PC. Now it is asking to fill in the blanks. This is a fill in the blanks problem. So the first one, we have to fill in the blanks with the less than sign or greater than sign or equal to sign. So the first one is saying PA plus PB dash AB. PA plus PB, PA plus PB should be this side. This is PA and this is PB. Definitely we can say that in triangle ABP, we must have the sum of the lengths of the two of the sides AP and BP greater than the third side, that is AB. So we must have AP plus PB should be greater than AB. So this must be greater than sign. Part 2, it says PB plus BC dash PB plus PC dash BC. So PB, PC and BC. So in triangle BPC, we will have PB, the sum of the lengths of the sides PB and BC, that is PB plus BC, should be greater than the third side, that is BC. So we must have greater than sign over here. Okay. The third one is AC dash PA plus PC. AC. Okay, so now we have to consider in triangle APC. In triangle APC, we have the sides AB, AP, PC and AC, and it is given that AC. Now we must have PC plus AP should be greater than AC. This implies that AC should be less than PC plus AP. AP or PA is the same thing. So third one will be less than. Okay. Let's solve problem number 4. AM is a median of triangle ABC. Prove that. Okay, so a figure is there. We have a triangle ABC. We have a triangle ABC, and it is said that AM AM is median of triangle ABC. Now AM is a median of triangle ABC. AM means a median is, now the median from the vertex A is nothing but the line that connects, that is the line which bisects the side BC equally, which bisects. So if this is M is the midpoint of the line segment BC. Now if we, so AM is the median, AM is a median. It is asking to prove that AM to prove AB plus BC plus CA is greater than twice AM. So we have the sides AB, we have AM, AC and BC. Now it is asking to prove AB plus BC plus CA is greater than twice of AM. Now what we can see, what we can know, we have two triangles. Okay, so in triangle ABM, we will have AB plus BM should be greater than the third side, that is AM. Also in triangle AMC we must have AC plus MC greater than the third side, that is AM. Now if this be inequality 1 and this be inequality 2, we can say adding from, if we add the two inequality from 1 plus 2, we have the first inequality AB plus BM greater than AM, and the second inequality is AC plus MC greater than AM. Now if we add the two inequality, meanings if we add the left hand side and the corresponding right hand side, we get that AB plus BM plus AC plus MC is greater than AM plus AM. Now this implies, if we simplify both the side, left hand side and the right hand side of the inequality, we get AB plus AC plus BM plus MC greater than twice AM. Now this implies AB plus AC. Now we can see that BM plus MC is nothing but BC is greater than twice AM, as we know that BC equals BM plus MC. Hence it is proved that AB plus AC plus BC is greater than twice AM. Okay. Let's do problem number 5. Problem number 5 says that in the given figure, P is a point on the side BC of triangle ABC. Okay, let's draw the figure first. We have the triangle ABC, and P is a point on the side BC of the triangle. Okay, it is asking to prove that this is problem number 5. Okay, it is asking to prove that that AB plus BC plus AC is greater than twice AP. Now AP. Now P is any point on the side BC. In the previous problem it was given that AM is the median. That is, AM was the midpoint of the side BC, even though this fact was not used in solving the problem. And in the problem number 5, it is given that P is just any point on the side BC of the triangle ABC. Prove that AB plus BC plus AC, AB plus BC plus AC is greater than twice AP. Now I think the solution will be same, because if we the solution will be same as problem number 4. So in triangle ABP we have AB plus BP greater than AP, and also in triangle APC we have AC plus PC greater than AP. So problem 4 and 5 are exactly same. From 1, adding the two inequality 1 and 2, we get AB plus BP plus AC plus PC greater than AP plus AP. So if we simplify further, we get AB plus AC plus BP plus PC is greater than twice of AP. Now this implies AB plus AC plus BP plus BC is BC is greater than twice of AP. We know that BC is equal to BP plus PC. Hence it is proved. Okay, let's solve question number 6. ABCD is a quadrilateral. ABCD is a quadrilateral. Okay, prove that. Okay, let's first draw the quadrilateral. We have this, this, we have this, and this. So the quadrilateral is like this: A, B, C, D, and the diagonals are joined. These are AC and DB are the two diagonals. It is we have to prove that uh, to prove AB plus BC plus CD plus DA is greater than AC plus BD. AC plus BD, that is, the sum of the length of the sides is greater than the sum of the length of the two diagonals. This is what we have to prove. Okay, so now we can see two triangles in triangle ADB. So these are the two diagonals. In triangle ADB, we can see that we have the lengths AD, sides AD, AB, and DB. In triangle ADB, we can say from the triangle inequality that DA plus AB is greater than DB PD. From the triangle inequality, we know that the sum of the length of two sides is greater than the length of the third side. So in triangle ADB, we can say that DA plus AB is greater than BD. Okay, and in triangle ABC, we can say that AB plus BC is greater than the diagonal AC. Let this inequality be 1, let this inequality be 2. Now from, if we add the two inequality from 1 plus 2, we get DA plus AB plus AB we are getting AB twice, AB plus BC, CD plus DA, CD plus DA. CD plus DA. So we have to incorporate the sides CD and DA. We already have DA, but we have to also consider the side CD. So it is better that if we consider the triangle ABC, it will not help because we are not engaging the side DC. We have to somehow engage the side DC or CD. So we have to consider in triangle ADC. In triangle ADC, we can say that DA plus DC, that is CD, should be greater than AC. Okay. So this is 2. Now if you do add the inequality number 1 and 2, we get DA plus AB plus over here it will be DA, again DA, ADB, greater than AC plus BD. AB DACD, AB DACD plus BC. Twice of, we are getting twice of DA. So we are getting DA plus CD is greater than BD plus AC. So on the right hand side we have got BD plus AC, or but on the left hand side we have got twice of DA plus AB plus CD is greater than BD plus AC. But on the left hand side we need BC. We need the side BC. We have to engage the side BC. This triangle. Okay, so we in triangle ADB we got this, we got this. I guess we have to consider more triangles. Let's see. We will not yet add the inequality 1 and 2, because we can see that four triangles, we can see four triangles has been formed in these quadrilateral sides and the two diagonals. One is the triangle ADB, another is the triangle ADC, and we can consider the triangle BDC. We can consider the triangle BDC, and we will have DC, we will have CD, because in the problem it is given CD. We will have CD plus BC greater than BD, and again in triangle, what triangle is left? We have considered ADB, we have considered ADC, and we have considered BDC, I think ABC. The triangle left is ABC. From triangle ABC we can say that AB plus BC is greater than AC, Now let's this be inequality 3, let this be inequality 4. Now let's see, if we add the four inequalities, we will get on the right hand side 2 times BD plus AC. Let's see. Now from 1 plus 2 plus 3 plus 4, that is, we are adding all the inequalities, the four inequalities, and we will get the left hand side. After adding all the left hand side of the four inequalities, we will get DA plus AB from the first inequality, then DA plus CD from the second inequality, and CD plus BC from the third inequality, and AB plus BC from the fourth inequality. This will be greater than, we will have BD plus AC plus BD plus AC. Now if you simplify, you will see the left hand side we have DA 2 times, AB 2 times, CD 2 times and BC 2 times. So we will have 2 times AB plus BC plus CD plus DA is greater than 2 times BD 2 times AC plus BD. So we can cancel the 2 from both sides and we get AB plus BC plus CD plus DA is greater than AC plus BD, and this is what it has asked to prove. Okay, let's see problem number 7. Problem number 7 says, if O is a point in the exterior of triangle ABC, show that, okay, so there is a triangle the triangle is ABC and there is a point O outside the triangle ABC. Let's say the point is O over here and it is joined, it is joining, the point O is joined with the vertices A, B and C. So we get the segments AO, BO and OC, and it is asked to prove, to show that, it is asked to prove twice of OA plus OB plus OC is greater than AB plus BC plus CA. Okay, so we have to consider the sides OA. We have the sides of the triangle ABC here. This also we have to consider the sides AO, OA, OB and OC. OA, OB and OC. Okay. Now in triangle, AOB, we have AO, sorry, it is given as OA. So OA plus OB should be greater than the third side, that is AB. Let this inequality be 1. In triangle BOC, we have OB plus OC greater than the third side, that is BC. Let this be inequality 2. So since it has been proved that on the right hand side, on the inequality greater than the right hand side, we have the sides of the triangle AB, BC and CA. We have to ideally consider the triangle inequality, so that by considering the triangles, so that we will have the sides AB, BC and AB, BC or CA on the right hand side of the greater than sign from the triangle inequality. That is why we are considering in the triangle AOB, we are considering AO plus OB greater than AB. We could have considered AB plus OB is greater than AO, but that would not help. Considering the relation, considering what it is asking to prove, we have to consider those triangles and the sides to apply the triangle inequality. Since it has asked to prove something greater than something, and we have on the on the right hand side of the greater than inequality, we have all the sides of the triangle ABC. So we have to keep this thing in mind. So that is the reason I am considering the while applying the triangle inequality in triangle AOB, I am considering that OA plus OB is greater than AB, so that I can add up all the triangle inequality and I will have all the sides of the triangle ABC on the right hand side of the greater than inequality sign. So in triangle we have AOB, we have BOC, and in triangle AOC, and in triangle AOC we will have OA plus OC is greater than AC. This is triangle inequality 3. Now if we add up all the three inequality, that is, we add up all the left hand side and the right hand side, corresponding left hand side and the right hand side, we get that OA plus OB plus OB plus OC plus OA plus OC greater than AB plus BC plus CA. Now if we simplify the left hand side, we will see we are having 2 times OA, 2 times OB and 2 times OC. So we will have twice of OA plus OB plus OC is greater than AB plus BC plus CA, and this is what it has asked to prove. Okay. So this brings to the end of solving the problems of exercise 15C. The main task in solving this kind of problem is to identify the triangles and then apply the triangle inequality, that is the sum of the length of two sides is greater than the third side. Now while applying this triangle inequality, you have to wisely choose which two sides, you have to choose the sides appropriately. That is, when you will choose the sum of length of two sides is greater than the third side, what third side you must choose, so that it will lead to the given it will lead towards the solution. That is the main task in solving this kind of problems based on triangle inequality. I hope this video was beneficial. If it is so, then please like it and share it with your friends, and also please do not and also if you are not subscribed to my channel, please subscribe to my channel, support me, so that it will help me grow my channel, and also it will motivate me to come up with these kind of videos on regular basis. And in the next video I will discuss about the last topic, which is Pythagoras theorem. So please stay tuned for the next video. And yes, that is all for this video. Thanks for watching, and until the next video, take care and bye.